Number 35, Rolle's Theorem. All right, Rolle's Theorem states it is an existence theorem. So we're checking to see if something exists. It says, let f be continuous on the closed interval, all right? So we've got our conditions immediately. We can only use Rolle's theorem if f is continuous, if there is a closed interval, and if it is differentiable on that open interval, right? We can't take the derivative at an endpoint, okay? So it has to be an open interval. All right, it says, if f of a equals f of b, then there exists at least one number, Let me show you what this looks like. Okay, so basically, here's what we're saying. Oh, that's from the last video. Pause. All right, here's what we're saying. We are saying that it says if f of a equals f of b. So I'm gonna make a point A. Say this is A, I make a point B. So I have a point A and I have a point B, and it says that f of A is equal to f of b. So this theorem only works if f of A is equal to f of b, or my outputs or heights are the same, okay? It says that there exists at least one number c somewhere in here where f prime of c equals 0. Okay, so remember that f prime of c equals 0 means that we've got a horizontal line, right? So we've got a horizontal line there. So think about it. No matter what's happening here, how I connect them, there's got to be one place where the slope is horizontal, the tangent line's horizontal. Because I could connect them straight across and make a horizontal line, right? That's one option. Or it could go like this, and we would have a maximum. It could go like this, and we would have a minimum, right? It could swirl around like this and have lots of minimums and maximums. But no matter what, we've got at least one point somewhere in this interval where we have a horizontal tangent line, or where the slope of the slope is equal to 0. The derivative is equal to 0. Okay, so that's what this theorem states. Now let's see how it looks in terms of a problem. Okay, so here's our example problem. Determine whether Rolle's theorem can be applied. Okay, so we have 3 things that have to happen. We have to have it be continuous, it has to be differentiable, and f of a has to equal f of b. If that's all true, then we can find where that tangent line, that horizontal tangent is. Okay, so let's figure it out. So for one, the first thing is that we want to make sure that f of x is continuous. Okay, f of x is continuous because x to the 4th minus 2x squared, that's a polynomial. It's going to be just some kind of curvy line. It is not going to have any holes or jumps or asymptotes. So it is, we can just say that, okay? It is continuous because it's a polynomial. Okay. Then f of x, we need to say, is differentiable. Again, because it's a polynomial, we're not going to have anything weird happening there. So your polynomials are pretty safe. Okay. Then we need to make sure that f of b equals f of a. So we want f of, my interval is -2 to 2, so I need f of 2 to be equal to f of -2. So let's double check that. We would have 2 to the 4th minus 2 times 2 to the 2nd. 2 to the 4th is 2 times 2 times 2 times 2, so that would be 16. Minus exponent first, but it doesn't really matter, 16 minus 8, so that would give me 8. F of -2, that's going to be the same because I've got even powers, right? So -2 to the 4th, that's going to be a positive 16, minus 2 and then -2 squared, that would give me a positive 8, so I would get 8. So that works. Okay, so I've checked all my conditions. Now it says, if so, find C, right? So now I can look for C. So I want where the derivative, or the slope, is equal to 0. So take the derivative first. I would have 4x cubed minus 4x is equal to 0. I can factor out a 4x, and I would have x squared minus 1 equals 0. This I can factor even more, so I'd have x plus 1 and x minus 1 equals 0. So then my x's would be 0, x equals -1, and x equals 1. But I want to check on my interval. Those are all on my interval, so those are all my values of C. Okay, so really this should say, sorry, C, C, C. All right, next. Okay, so again, we need to check our, oh, so this one's, sorry, this is not automatically mean value theorem, or sorry, Rolle's all the theorems. Let f be a function that is differentiable on the interval 1 to 10. So we already know it's differentiable, right? So we can say, and if it's differentiable, it's also continuous. So f of x is continuous because it's differentiable. 2, f of x is differentiable because it's stated, it's given. Okay, so our conditions are out of the way in case we want to use Rolle's theorems. Now, it says okay, anytime I see this, my mind immediately wants a graph. F of 2 is -5. Then f of 5 is equal to 5. Okay, and it doesn't have to be a perfect graph, which is why I'm not using graph paper. And f of 9, it's really making me extend this way, 5, 6, 7, 8, 9, is -5. Okay, so which of the following must be true? So it's asking me to think about my theorems. So remember, my theorems that I've learned so far are the IVT, the MVT, and Rolle's. Okay, so there's my options. So f of 2 has at least 2 zeros. So yeah, I can see that if I'm going to connect all of these, it's got to have a 0 here and a 0 here. I need to think about, is it because of IVT, MVT, or Rolle's? Remember? So IVT says that if I have 2 outputs, I have to pass through all the outputs in the middle, right? It's impossible to pass through these middle pieces if I'm going to connect these 2. So that is what's forcing us to have zeros here. So this is by IVT. Okay, so this is true. 2, the graph of f has at least one horizontal tangent. So now my theorem about horizontal tangents is the one we're working on right now, Rolle's, right? I know that this one, this output, right, f of 2 is equal to f of 9, right? So now I found my third criteria for Rolle's theorem. Oops, sorry, f of positive 9. I found my third criteria there, so I know that this one must be Rolle's. So if you're asked for a horizontal tangent, that means that it must be Rolle's, okay? And then MVT, or sorry, wow. So T2 needs to be true. Can you tell I've done like a lot of videos in a row, and this is definitely my last one? Sorry, guys. All right, for some C in the interval from 2 to 5, f of c is equal to 3. So in between 2 and 5, so just here, f of c has to be equal to 3. So I'm just looking at this part. Is it true that I have to pass through a height of 3, right? Because f of c, that's output. Height of 3? Yeah, I can't get from -5 all the way up to 5 without crossing through 3. So that one, again, is IVT. Okay? We did not have any mean value theorem in here. Remember, mean value theorem is comparing I rock to A rock, and we didn't have any mention of that in here. The slopes were not mentioned. So Rolle's theorem is about our horizontal tangents. IVT is about some output that has to happen, whether that be a 0 or a number like R3. And then Rolle's is asking about our horizontal tangents. All right, there you go.